Hello, namaste everyone. Hope all of you are well. In this lecture, especially lecture number 5 I'm talking about, we'll discuss general characteristics of the compounds of alkaline earth metals as the things we have discussed about in the lecture number 3 of general characteristics of the compounds of alkali earth metals. If you have not seen that video, lecture number 3 of S block elements, then just go through my channel, watch lecture number 3. There is the same video, but it is of alkali and this is of alkaline earth metal. That lecture number 3 is of alkali earth metal. Same way, whatever we are going to study, it will be of same things, just like lecture number 3 only. In this video, we will specially discuss in the general characteristics like the chemical reactions of all the alkaline metals with oxides and hydroxides, halides, salts of the compounds like carbonates, sulfates and nitrates, anomalous behavior of beryllium, diagonal relationship of beryllium and aluminium, some important compounds of calcium like calcium carbonate, calcium oxide, calcium hydroxide, that is also known as quicklime, slakelime and marble, the formation of cements. Means these are all the things if you are going to be in BSc chemistry or you are going to specially go into the chemical field like chemist, quality control, quality analysis or production or research and development. That time specially I am talking about the topic called some important compounds of calcium. It will be very useful, and the last topic will be the biological importance of calcium and magnesium. These are all the things we are going to study in this video, and I'll try to give you special about this some important compounds of calcium in one more video. Special I will discuss in this general characteristics of the compounds of alkaline earth metal. As you know very well, all the alkaline earth metals have a valency 2, means divalency, you can say. It is written in your NCERT textbook also. If you have your NCERT textbook, then you can see on the general characteristics of the compounds of alkaline earth metal as the di-positive oxidation state. Di-positive means, you know, the di-positive means 2 electrons. It can donate 2 electrons from its outermost orbit. So it is the predominant valence group 2 elements. All the alkaline earth metals form compounds which are predominantly ionic but less ionic than the corresponding compounds of alkali metals. This is due to the increased nuclear charge, smaller size, and the oxides and other compounds of beryllium and magnesium, which are more covalent than those formed by the heavier and large size member of calcium, strontium and barium. The general characteristics of some of the compounds of alkaline earth metals will be discussed as oxides and hydroxides. So first of all, dear student, if we compare alkali and alkaline earth metals, right, group number 1 and group number 2, alkali earth metals and alkaline earth metals. Right? This is group number 1 and this is group number 2. So you know very well, as we move left to right in the periodic table, what happens? The atomic size decreases. Right? Atomic size decreases. If the atomic size will decrease, then what things you can correlate with group number 1 and 2? We can correlate that the nuclear charge will increase, right, because of the smaller size. From group number 1 and 2, if we compare these both, then can you tell me which will be more ionic, group number 1 or group number 2? Group number 1 will be more ionic than group number 2. So the things which I am making you to understand, group number 1 and 2, first we are correlating, because group number 1 from lithium to cesium, the things which we have studied will be similar as beryllium to barium. So here in that, lithium was showing anomalous property and anomalous behavior. Here beryllium will show. Similarly, there lithium and magnesium was having diagonal relationship. Here beryllium and aluminium will have diagonal relationship. So the things which are same only, but little bit difference That was +1 valency. Here it was +2. So it is monovalent and it is divalent. It can lose 2 electrons, it can lose 1 electrons. So here first of all, make a relationship between the group number 1 and group number 2, and now we will discuss the general characteristics. The first characteristics is oxides and hydroxides. Oxides, which we have already discussed in the chemical reaction in lecture number 4, I have shown you the chemical reactions of group number 2 elements, means reactions of matter, means this is the group number 2 metal, right? When we do the reactions with oxygen, it generally gives you metallic oxide, because here the oxidation state, or you can say the valency, is 2, right? So here it will give you the formation of metallic oxides. Here both the compounds will have +2 and -2, right? As you have understand about. Now if after the oxide there is one more compound called hydroxide. Hydroxide means reactions with water, right? So as we talk about the hydroxides, so you know very well here, MO plus H2O, metallic oxides plus water, that is metallic hydroxide, MOH whole twice. General reactions about this group number 2 elements. Now if you talk about these oxides and hydroxides, then the alkaline earth metals burn in oxygen to form monooxides, which is except for beryllium oxide. Because beryllium oxide have a rock-like structure, beryllium oxide is essentially covalent in nature. The enthalpies of formation of these oxides are quite high, and consequently they are very stable to heat. So beryllium oxide is amphoteric, while oxides of the other elements are ionic in nature. All the other oxides except beryllium oxides are basic in nature and react with water to form sparingly soluble hydroxide. So here there is one exception. Dear student, when this beryllium reacts with oxygen, it gives you beryllium oxide. So this beryllium oxide is having amphoteric nature. Amphoteric nature means you know very well, it can give you acidic and basic nature both. And rest of this beryllium means after the beryllium, which of the compounds are there? Magnesium, calcium, strontium and barium. Radium is already a radioactive element. So here as I have shown you, so except this beryllium oxides, the rest all the oxides will give you basic nature. The rest all the oxides will give you basic nature, and beryllium oxides will give you amphoteric nature. So here beryllium is an exception. In group number 1 there was lithium was an exception. Here beryllium as reaction with oxygen means burning, you know very well. So here as the beryllium burn, beryllium is having a rock like structure, first of all remember that. So beryllium will give you a covalent nature in this compound. And here the oxides, which are very high, and consequently they are very stable also to heat. So this thing you have to remember. Now except beryllium oxide, rest all the elements. Here means if I talk about these elements, if these elements react with water, they will give you hydroxide. Hydroxide means basic in nature, right? So here you can see that MO plus H2O gives MOH whole twice. The solubility, thermal stability and the basic characteristics of the hydroxides increase with increasing atomic number from magnesium oxide to barium hydroxide. Means you know very well thermal stability. What is this thermal stability and solubility? So if we increase the atomic number in group, then stability of basic character of this hydroxide will also increase from magnesium hydroxide to barium hydroxide, and the alkaline earth metal hydroxides are however less basic than alkali earth metal hydroxide. So beryllium hydroxide is amphoteric. It reacts with acid and alkali both. So it will give you a berylate ion, means beryllium hydroxide reacts with alkali and acid both because it is having an amphoteric nature, and after doing the reaction it will give you berylate ion, means. So here first of all I would like to say you, dear students, If we talk about alkali and alkaline earth metal, which is more basic, then you can see the group number 1 and group number 2, right? Group number 1 means alkali earth metals and group number 2 alkaline earth metal. So more basic, this will be more basic and this will be less basic. So alkali earth metals are more basic and alkaline earth metals are less basic than alkali earth metals. So when this, if I talk about the beryllium, so when this beryllium oxides reacts with water, what it will give you, you know? Means beryllium oxide will give you berylate ion. Means you must see the reaction of beryllium oxides, beryllium hydroxide, and since it is giving a reaction in acid and base both, so that's why beryllium hydroxide plus 2OH, beryllium hydroxide plus this is called berylate ion. What is this called? Berylate ion. Remember this formula, berylate ion. And if this beryllium hydroxide reacts with acids, acids means you know that very well, you know, BeOH halt twice will react with HCl and water. Okay, so what will be the compound? Can you say me? Same compound, but here chlorine is there because in the acidic form chlorine portion is there. So what will be the BeOH halt 4 into Cl2? Means berylate ion will be dissociated and chloride ion separately and the berylate ion separately. 2 plus and 2 minus. Here 2H2O. So no need to worry, dear students. It will be beryllium hydroxide, that's called berylate ion. Here it will be 2 plus and this will be 2 minus. Okay. So it can react with base also, it can react with acid also, because this beryllium is amphoteric in nature. Beryllium is amphoteric in nature. So this was the first topic. Now we are talking about the second topics, that is called halides. Halides means you know very well, here metal is in divalency, M is in the form of 2, and if it reacts with X, then it will give you, X means here halogen, fluorine, chlorine, bromine, iodine. If you do the reaction in the form of X2 or X, then it will give you directly MX2. In the form of magnesium, calcium, strontium, barium. Here metal 2 plus ions will give you, except beryllium, I have not written that beryllium, except beryllium, all the other halides of alkaline earth metals are ionic in nature. Beryllium halides are essentially covalent and soluble in organic solvent. Beryllium chlorides has a chain structure also. Remember, dear student, chain structure which shows as a solid state. So except beryllium hydroxide, all the other salts are ionic in nature. Means beryllium is showing here. Means if I talk about the beryllium salt, so remember, dear student, it will show like this structure. Means solid structure, solid chain structure if I talk about. So here this beryllium will again show like this structure. It will go on again and again. Got it? So this solid chain structure, all the other metals means alkaline earth metals are ionic in nature. Ionic in nature. And here beryllium chloride, it is covalent in nature. Got it? So the difference between the beryllium and other alkaline earth metals halides, you know very well. Except for beryllium halides, all the other halides of alkaline earth metals are ionic in nature. Beryllium halides are essentially covalent and soluble in organic solvent. What is organic solvents? You know very well. Alcohol, acetic acid. So these are the organic solvents. Beryllium chloride has a chain structure in the solid state. So as you can see that covalent in nature, as I have written, this chain structure is in solid state. Now one more properties I am talking about the beryllium chloride it is having a tendency to form chloro bridge dimer which dissociate into the linear monomer at the high temperature of the order 1200 Kelvin. The tendency to form these hydrates gradually decreases. Magnesium chlorides hydrated form, as we have discussed earlier also. Magnesium MgCl2 into 8H2O, calcium chloride into 6H2O, strontium chloride into 6H2O, beryllium chloride will be formed in the 2H2O. Means as we move down towards the group, it will decrease and increase, except beryllium. Means beryllium here, BeCl2 into 2H2, right? Hydrated form. If I talk about the magnesium, MgCl2 into 8H2. If I talk about calcium, CaCl2 into 6H2. If I talk about strontium, strontium chloride into 6H2. So this hydrated form, as you can see, this compounds of beryllium to strontium. What you have noticed, as we move down towards the group, the hydration of hydrated chlorides or bromides and iodides of calcium and strontium and barium, which can be achieved on heating. However, the corresponding hydrated halides, fluorides, are relatively less soluble than the other, like chlorine. Chlorine is owing to their high lattice energies. So this was the halides. Dear students, when we talk about the halides also, then also we have to remember one word, that is beryllium. Beryllium is having very small atomic size. Since it is having a small atomic size, it will give you the covalent in nature. The rest of the alkaline earth metals will give you ionic in behavior or ionic in nature. As you can see, this hydrated. As we increase the temperature, so the beryllium chloride will be in the vapor phase, chloro bridge dinner, which can be dissociated into the linear monomer. When? Because if you give the 1200 Kelvin high temperature, then they will give you the hydrates decreasing form. Decreasing form means from magnesium to strontium, you can see it was 8H2O, 6H2O, 6H2O. So decreasing form of hydrates and hydrides form. Okay. Now next topic is salts of oxoacids. What is the meaning of this salts of oxoacids? Oxalic acid, many times I have informed you what is the formula of oxalic acid. When two carboxylic acid mix, this is called oxalic acid, right? And when this oxalic acid dissociate to H plus and COO minus, this is oxalate ion, and oxalate ion, when they form the salts, either carbonates, sulfates or nitrates. So all the alkaline earth metals except beryllium, or you can say beryllium also here, these form the salts of oxoacids like carbonates. Carbonates of alkaline earth metals are insoluble in nature, and it can be precipitated by the addition of sodium or ammonium carbonate solution to a solution of soluble salts of metal. The solubility of carbonates, water decreases in the atomic number of the metal, iron increases. All the carbonates decompose on heating to give carbon dioxide and the oxides. Beryllium carbonate is unstable and can be kept only at the atmosphere of carbon dioxide. The thermal stability increases with the increase in cationic sizes. So dear student, if we talk about this carbonates, carbonate means you know very well. Can you tell me what is the carbonate's formula? CO3. So except beryllium, all the other alkaline earth metals from magnesium, calcium, barium, strontium, this alkaline earth metals, how they will give you the carbonates form, you know? Means if I talk about all the other alkaline earth metals, when they react, they give you the carbon dioxide forms. How do they give? They give carbon dioxide forms. Carbon dioxide form means you know very well. CO2 they will release it, right? So carbonates, how these carbonates have came from oxalic acids, or you can say that carbonic acids also, H2CO3, right? Carbonic acid, H2CO3, it dissociates into 2H plus CO3 2 minus. When this all the elements, beryllium, magnesium, calcium, strontium, barium. Means except beryllium here. If we do this reaction, carbonates, so you know very well which type of compounds they are going to form. MgCO3 magnesium carbonate, calcium carbonate, strontium carbonate, barium carbonate. And if I talk about beryllium, can you tell me what will be the compound of beryllium carbonate? Beryllium carbonate will be also there. As I have informed you that carbonates of all the alkaline earth metals which are insoluble in water, not soluble, it is insoluble in water, and can be precipitated by adding sodium ammonium carbonates solution to a solution of soluble salt of this metal. As the solubility of these carbonates in water decreases, the atomic number of the metal increases, metallic ion increases. All the carbonate decompose on heating to give carbon dioxide and the oxide. But beryllium carbonates are unstable and it can be kept only at the atmosphere of carbon dioxide. So thermal stability will increase with increase in cationic size. Thermal stability will increase in cationic size. So here it will give you beryllium carbonate, but the thermal stability will be, as I have informed you, as the cationic size here means Mg or any metal, if I talk about M2 plus, the cationic size will increase. The thermal stability of those solutions, why I am writing Mg, I should write M, not G. Directly if I talk about all the alkaline earth metals. So as this cationic size increases down towards the group from magnesium to barium, so as their cationic size will be increased, what will happen, you know? The thermal stability will also increase. The thermal stability will also increase. So these was the carbonates. Now we will talk about the sulfates. Sulfates means, you know, sulfuric acid. So this was carbonates. Now I will talk about the sulfates. Sulfates means sulfuric acids. Sulfuric acid formula H2SO4. H2SO4 breaks down into 2H plus plus SO4 2 minus. So when all this metal will do the reaction with SO4, it will give you MSO4. Right? Sulfates of these alkaline earth metals. The sulfates of all the alkaline earth metals are white solids and stable to heat. Beryllium sulfate and magnesium sulfate are readily soluble in water. The solubility decreases from calcium to barium sulfate. The greater hydration enthalpies of beryllium 2 plus and magnesium 2 plus ion overcome the lattice enthalpy factor, and therefore the sulfates are soluble in water. The sulfates of all the alkaline earth metals are white solid and they are stable to heat. So except beryllium and magnesium, means they also heat, but if I talk about beryllium sulfate and magnesium sulfate, these two can easily, means you can say rapidly, it can easily be solution in water, right? So here beryllium and magnesium sulfates are readily soluble in water, but from calcium to barium sulfate, means calcium sulfate, strontium sulfate and barium sulfate. These all are not readily soluble in water as the beryllium sulfate and magnesium sulfate are. But calcium to barium sulfate decreases the solubility. Here the solubility increases, means it can be easily soluble. But here, as you move down towards the group, the solubility decreases. Got it? Now you can ask me, sir, here beryllium 2 plus and magnesium 2 plus are that right? Yes. So these ions overcome the lattice enthalpy factor, and therefore their sulfates are soluble in. It means here lattice enthalpy factor is present in this MgBe 2 plus and Mg2 plus. So that's why they are easily soluble in water, and this do not show this lattice enthalpy factors. They are not, means they show, but it is not show as this beryllium and magnesium as well. So this was our topic called sulfates. Now we will talk about the nitrates. Nitrates means nitric acid, HNO3, right? Nitric acid formula HNO3. This dissociate H plus and NO3 minus, right? And here magnesium is 2 plus and nitrate is 1 minus, right? So the formula will be MnO3 twice, right? So here M means all the alkali earth metals. So if I talk about the nitrates, then the nitrates which are made by dissolutions of carbonates in dilute nitric acids, magnesium nitrate crystallizes with 6 molecules of water. So remember, dear student, as we are discussing copper sulfate CuSO4 into 5H2O, similarly magnesium nitrate MgNO3 hold twice into 6H2O. This crystallizes with 6 molecules of water, whereas the barium nitrate crystallizes an anhydrous salt. So this again shows the decreasing tendency to form hydrates. As the atomic size increases, the hydration enthalpy will decrease. So all the decomposition of, on heating to this, they will give the oxides like lithium nitrate was giving. Similarly, here the magnesium or beryllium, magnesium, calcium and strontium and barium, if we put a reaction 2M NO3 halt twice, 2M NO3 halt twice, what will be the reaction, you know? Here the nitrates are there, right? As we heat, can you tell me what will be the compounds? Here magnesium oxides, nitrate, nitrogen dioxides and oxygen. Means here 2MO plus 4NO2 plus O2. Just balance. Is this reaction balanced? You can see here 2 magnesium, 2 2s are 4 nitrogen and 3 2s are 6, 2s are 12 oxygen. 4 2s are 8 to 10 to 12. Yes. So the reaction is balanced. So as you have seen here about the nitrates, so just similar like lithium nitrates here also, as the atomic size here increases, the hydrates will be, means the hydrations, or it will increase by the atomic size increases, so the hydration enthalpy will decrease, right? Now one more thing I want to say about this 3 properties of salts of Oxo acid. So here carbonates means, remember, carbonic acid, sulfates means sulfuric acid and nitrates means nitric acid. So when this metallic salts give you the formation of metallic carbonates, metallic sulfates and metallic nitrates, how do they show? Especially in this type of topic, the things which will be asked is that which of the compounds are more soluble, which of the compounds show more lattice enthalpy, which of the compounds show less lattice enthalpy or less hydration enthalpies. I hope all of you have understand about this nitrates. Now the next topic is anomalous behavior of beryllium. What is anomalous behavior? As I have informed you in the group number 1 also, lithium anomalous behavior. Similarly here we will talk about the beryllium anomalous behavior. What is this anomalous behavior, dear students? Beryllium is the first member of this group number 2 alkaline earth metals. It shows the anomalous behavior as compared to magnesium and rest of the member. Further, it shows the diagonal relationship, aluminium, which is discussed subsequently. First of all, dear students, beryllium, magnesium, calcium, strontium, barium, radium, boron, aluminium, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, helium, neon, argon. So as we have seen here, that lithium shows diagonal relationship with magnesium, beryllium shows with aluminium. So similarly here, if I talk about this anomalous behavior, because of the atomic sizes, beryllium is exception. Rest all the elements of this group number 2 show the relationship to aluminium, which is diagonal relationship, but beryllium has an exceptionally small atomic sizes. What? Small atomic sizes, which can't give you the ionic property, but because of the small atomic and ionic size, it does not compare well with other members of the group. Because the high ionization enthalpy, small size, it forms compounds which are largely covalent and get easily hydrolyzed. Means this beryllium gives you the covalent compounds, and rest of the elements will give you ionic compounds because it is having the small atomic size. And if I talk about the ions of this compound, means beryllium 2 plus, then because it is having high ionization enthalpy, small size, so it will form a large covalent compound. Large covalent compound means it will give you a large covalent compounds with halogens, and it can be easily hydrolyzed, means it can easily react with water. So beryllium does not exhibit coordination number more than 4, as its valence shell has only 4 orbitals, so the remaining member of the group can show a coordination compounds of 6 by making uses of d orbital. Dear students, here which we will discuss in the class 12 coordination chemistry, in that you will see beryllium will not give you more than 4 ligands, but this can give you more than 6 ligands or 6 ligands. Here it can maximum give you 4 ligands, they can give you 6 and 8 ligands, because here beryllium atomic size is small and it is not having more than 4 vacant orbitals, but here they can give you the vacant d orbital, so it will be formation of coordination compounds, but beryllium will not give you. Beryllium will show only 4 coordination number, because in the valence there will be only 4 orbitals, right? And rest of the elements will give you 6 or 8 because of the vacant d orbitals. And the oxides and hydroxides of beryllium is unlike the hydroxides of other elements in the group, because they are amphoteric in nature. Amphoteric means here it will give you acidic also, it will give you basic also, but these all will give you only and only basic nature, because it is having amphoteric and these are basic in nature. So that's why here amphoteric natures means little bit different from the other alkaline earth metals, so that's why it is written anomalous behavior of beryllium. Now next is diagonal relationship between the beryllium and aluminium. The ionic size of beryllium 2 plus, which is estimated to be 31 picometer, and the charge by radius means ratio, which is nearly same of aluminium 3 plus ion. Hence beryllium resembles aluminium in same way. Some of the similarities, like aluminium, beryllium is not readily attacked by the acids because of the presence of an oxide film on the surface of the metal. Beryllium hydroxide dissolve in excess alkali to give berylate ion, that is BeOH whole 4 twice 2 minus, just as aluminium hydroxide gives aluminate ion. And the chlorides of both beryllium and aluminium have chloride bridge chloride structure, which is in the vapor phase. Both the chlorides are soluble in organic solvents and the strong Lewis acid. They are used as a Friedel-Crafts catalysis. Beryllium and aluminium ions have strong tendency to form complexes like BeF4 2 minus, AlF6 2 minus. So dear student, the relationship of this beryllium and aluminium ion, beryllium 2 plus and aluminium 3 plus, because of the same atomics and nearby same, not 100% same, but nearby same. So that's why they are giving this relationship, that how this beryllium can give you the relationship between aluminium, because of the ratio of their atomic sizes or ionic sizes. You can see beryllium resembles aluminium in this way. If we talk about the ionic size of beryllium 2 plus, that is 31 picometer. How much? 31 picometer. And in the physical property you may have seen, means in the lecture number 4 I have discussed about all the atomic sizes and ionic sizes. So here there you can compare. Similarly, as beryllium is giving berylate ion, aluminium also give aluminate ion, AlOH4 minus. Beryllium can reacts with fluorine or chlorine. It will give you the structures in the vapor phase which is soluble in the organic solvent, and strong Lewis acid also. So that's why they are used as a Friedel-Crafts catalysis. Beryllium and aluminium gives the ion with the tendency to form complexes with fluorine like BeF4 2 minus, BeF4 2 minus, and AlF6 2. So can you tell me the properties of beryllium and magnesium? No, aluminium will show 3 plus, no? So that's why here it will be 3 minus. Right. So here the properties of the diagonal relationship between the beryllium and aluminium as I have discussed. Now the important compounds of calcium. I am trying to show you one more video because these things are very important and I don't want to complete in this video. So that's why the calcium compounds like calcium oxide, which is also known as quicklime, slicklime, calcium carbonate as a marble. So these are all the things, preparation, physical and chemical properties and uses of this calcium compounds and beryllium, importance of calcium and magnesium will be shown in the next video. As in this video we have discussed about the general characteristics of the compounds of alkaline earth metals as oxides and hydroxides, halides, salts of the oxoacids as sulfates, carbonates and nitrates, anomalous behavior of beryllium and diagonal relationship between the beryllium and aluminium. So these was our topic in this video. In the next video I will show you about the important compounds of group number 2, alkaline earth metals as calcium carbonate, calcium oxides, calcium hydroxide, which are also known as, here calcium oxide is known as quicklime, slicklime, marble. And one more property that I will show you, that if you enter into the chemist field, that in which factory what the things are being used. Whatever the things you are studying, it must be related to your daily life. If you have interest to go into that field, knowledge priority. You must give the knowledge priority. Don't learn only to get marks. Something which must be used in your life. Learning and getting marks both are two different things. If you are only studying, then it will be getting marks. But if you are learning, then you can utilize these things in your daily life. That's all for today. Thank you very much. If you have any doubt related to this video, then drop it out into the comment box section. Don't forget to like and subscribe the channel. Share this video with your friends so they can be also benefited. Thank you very much.